Good luck, my friend, and thanks for making yourself available. Much appreciated.
Yeah, not a problem. Thanks so much for putting this together. This is a fantastic event, and oh man, I feel bad for the guy that has to follow up Scott's presentation. Oh, wait, that's me. Sorry.
Oh
I'll do
no,
my
but
best.
your session content, the title itself, it's amazing. So it's a much needed subject for nowadays. So take it away, bro.
Definitely. Yeah, especially now more than ever. Sorry, I'm just gonna go ahead and share my screen. Can you just give me a yay or nay that you can see the slide deck? All right.
You got it. Yep.
Perfect. All right. Yeah. So, hello everyone. For those who just came in just now that missed, my name is Chris Piasecki, and today my session is going to be on Power Platform application lifecycle management and using Azure DevOps. So just a bit before we get into that, a little introduction. So I'm a senior CRM.NET developer, currently working at CGI. I hail from the capital of the Alberta region. I know I see Victor probably shaking his fist in the background. He's from Calgary, so there's a bit of a rivalry between our two cities when it comes to some of our sports, such as hockey. But nonetheless, yeah. And so I've been working with CRM for about the last 5 or so years, and more recently Power Platform, and about 9 years overall experience in the industry as a developer. For those who want to connect with me after the session, if you have any sort of follow-up questions I'm not able to answer today, feel free to connect to me on LinkedIn. You can see the QR code below. You can just scan that and I'll take you right to my profile. But I'd be happy to connect with you and strike up a conversation or answer any questions that I can't get through today. So a little bit of trivia or fun facts about our great nation, Canada. So for those who don't know, the capital of Canada is Ottawa, and in Ottawa we have what's called the Parliament Hill, which is kind of like a sort of the central or nation's capital, kind of a sacred area on that land. And we have what's called the Parliament Hill flags, and there's 5 of these, and these are basically hung up on Parliament Hill, one of them on the Peace Tower, a couple of them on the East Block, and another 2 on the West Block. And these are basically changed out every weekday or in the event of a half mass. So usually that would be typically our Remembrance Day holiday that kind of honors the soldiers, or in the event of sort of any tragedy where we lose, some very important people. And so every year, actually, about 250 different flags fly on the Peace Tower, and then about a couple hundred between the East and West blocks. And the interesting part about this is that as a Canadian citizen, you actually have the right, basically, to request one of these flags that are hung up on Parliament Hill. Now, however, you might be waiting a while to get one of these flags. Currently, the waiting list is actually over 100 years, so chances are you may not still be here when it actually finally comes to reaching you on the list. So, interesting fact I thought I'd share for those who are looking to know more about our fine nation. Okay, so to the topic of today. So, what are some key takeaways I hope that you can all take after hearing my presentation? So, hopefully by the end you'll understand general application lifecycle management concepts, and then as well specific concepts that apply within the Power Platform. Hopefully we can instill some best practices around ALM. Of course, I'm going to make you aware of some of the ALM tooling and capabilities of those. And then hopefully by the end, then it'll give you some starting points and ideas where you can then go and implement some ALM practices in your organization if you're just getting started or don't have anything in place today. So just a quick overview of the agenda. So we're going to go over some ALM concepts, and then specifically some within the Power Platform, tooling, some general common patterns that we use for development in ALM. And then I'm going to jump into some demos, and we're going to be specifically using Azure DevOps, which I'll get into in a little bit. I'm going to show how we can put together some continuous integration, continuous deployment demos using Azure DevOps. And then we're going to basically wrap up with some final, best practices and general recommendations, and then we'll complete with a recap, final thoughts, and time for any questions. Okay, so what is application lifecycle management? Well, it's essentially the product lifecycle management of software applications, really starting from the beginning of planning or inception of the solution all the way up to ongoing, maintenance of the solution after it's gone live, and then, of course, the eventual end of life of the application. So some of the key concepts that are involved in ALM, we would have your governance, which basically focuses on different management procedures such as change management, requirements management, release and deployment management, and then ongoing access management and security monitoring such as auditing. And then of course you have your typical software development lifecycle kind of within that, which really involves the sort of plan, typical plan design, building, testing, and then of course tracking issues throughout that life cycle. And then finally you have the actual maintenance. So how do we go ahead and actually manage the system once it's actually gone live and the users are using your system in production. So we have a number of key stages that actually comprise these processes. And so you have, as I mentioned, all the way from planning up to your development, building, testing, getting ready for release, then going ahead actually deploying that into your environments, and then the ongoing operationalization of that, maintaining that that piece of software, and then ongoing monitoring of the solution and basically capturing feedback and basically going on and improving. And this is a cyclical process. So you'll go from plan all the way up to the monitor, all the way in a cyclical fashion. This could be as frequent as days, weeks, or months, right? Whatever sort of ALM your organization has in place. So kind of a buzzword that everyone's really using lately, and that's DevOps. So really, what is DevOps and where does it come into play with ALM? And so DevOps is really just a set of practices that combine your traditional software development teams and your IT operations teams, hence the dev and the ops. And it's basically, coming together and collaborating and basically, combining of people, processes, and tools. And so really some of the goals of DevOps is really first and foremost, looking to actually start to automate, a lot of your build and deployment processes, which then, really is kind of the catalyst to, increased velocity and, speed to market, right? Getting your product out to your customers as soon as possible. DevOps really looks to also, achieve higher quality and delivered software through, consistency, and that's again achieved through that automation. And really, it looks to push changes out much faster, and therefore, as a result, smaller batches of changes, which often leads to more satisfaction in your customers, because you're not rolling out very large changes every 6 months, and then when it reaches your end customers, they become sort of surprised and thinking, oh, that's not what I asked for. But that can be really avoided when you're pushing just small incremental changes out to the customers, and you can get that sort of continuous fast feedback and collaboration between your customers and your team. So some of the kind of key principles and practices you'll hear is, you have your continuous integration. And so what that really means is that your team wants to be, taking changes and merging them together often as possible. This could be, hourly or daily or by, weekly. It really depends on the sort of the maturity or what your organization sort of has in place today. Then you have your continuous delivery, which basically builds on that continuous integration. And really what continuous delivery focuses on is essentially having that readiness to deploy your version at any time. But you'll still have some manual processes in place to do actual deployment, right? You may need to get sort of manual approvals before you go ahead and push release and push the software out to your customers. And continuous deployment is kind of the final phase, and it's kind of like the place that kind of every DevOps practice kind of strives to achieve, and that's sort of that continuous deployment. And so the whole end-to-end process becomes fully automated without any human intervention. And so if your changes pass through every sort of stage and gates through your continuous integration and continuous delivery and continuous deployment pipelines, it gets pushed out without needing to actually involve a human. Now, continuous, most organizations, I think, it's a great strive to really hit that continuous delivery, right? Continuous deployment is not necessarily all that common. You need to have some real maturity to actually be able to reach that stages. But really where you start to get that value is if you actually have continuous integration in place and continuous delivery in place. So that, that continuous deployment is a nice to have, but it's, it can be very challenging to actually reach that level of maturity. And so another way of kind of visualizing that is sort of the progression of an organization. So you can see with continuous integration, you have the whole automation put in place, and that's, once you've actually developed, you push your changes and merge them into source control. You have it'll kick off automated process to run things like unit tests and other quality checks. And then, continuous delivery will expand that a bit and have actual, deployment and release pipelines ready to go, but they will still, require a human to actually, approve those changes and approve the deployment to actually kick that off. And then finally, your continuous deployment, that takes that a step further, and again, fully automated end-to-end process where the solution is then, released and deployed out to your customers. So what are some of the, kind of important ALM concepts that apply in the Power Platform? So we have a number of different, key components that we work with all the time. So we have things like your Dataverse, which is, formerly your common data service database. These always are going to reside within what is called environments, which are basically the containers for, all of your different components, such as your apps, your Dataverse database, and your solutions, right? Other important things that come into place is a source control, which we'll get a bit into, and then some of the DevOps tools that we can use to actually apply ALM to that. So some of these I'm going to go into a little more detail than others, but just these are kind of the key concepts that and everyone should sort of be aware of once you're going to actually implement some ALM into your organization. So really kind of one of the key concepts, probably one of the more important concepts for ALM in the Power Platform is the idea of solutions, right? And so solutions, have, been around since the earlier days of dynamic CRM, and they've become ever so more important now that, we're running in Power Platform and Dataverse. And so solutions, have now been expanded out so that you can include much more components than you used to in the past. Like we have now the ability to add Power Automate flows, your Canvas apps. Even more recently, you can now add, Power BI dashboards, directly into the solution. So we have things like, your custom connectors, where you can connect to your, custom developed APIs, right? And then actually more recently, we have things like connection references, which are supposed to really help with ALM and actually, connecting up to your connectors when you're moving between development and your other environments. That should hopefully take away some of the manual intervention that was previously required to reset up your connections as you bring your solutions into another environment. So I'm not going to go deep into this because the unmanaged versus managed solution, that debate could really take up a session on its own, or probably even its own conference, really, to be honest. But just kind of a quick recap, in that unmanaged are really meant to be within your development environments only, right? This is where you make your configuration and customizations, and then eventually, once they're ready to be pushed down into your testing or later environments, these get exported, and then hopefully you would unpack them into their sort of their original XML state, which can then be pushed into a source control repository where it can be easily viewed and compared and merged. And so your unmanaged solutions that sit within your source control repository should be your source of truth. And I'll get much more into this in preceding slides. Now, your managed solutions, of course, these are basically your compiled, your build artifacts that eventually get pushed into your downstream environments, whether that's your system integration testing, user acceptance, staging, production, etc. And in a ideal scenario, this managed solution should be actually generated by what we would refer to as a just-in-time build environment, meaning that a build environment could be spun up on demand just for the purpose of building a managed solution and basically exporting it out and pushing it to basically an artifact repository, which can then eventually be used in downstream release pipelines. So as previously mentioned, environment's another big component, right? That's kind of the overall container where it's going to hold all of your things like your solutions, your dataverse. I guess maybe dataverse, we're using it as a noun. Is it your dataverse or your dataverse database? Previously your common data service database. That's where all the business data resides. And so your environment strategy is really something that should be, sort of established upfront early into the development cycle. And, this is going to vary based on the needs and criticality of the system that you're looking to build for your customers. And so you may have, as little as maybe just a dev, UAT, and production environments. And that may be good enough for some of your customers' needs or your organization's needs. But, you can have as little or as many environments as you want, such as having, your just-in-time build environments, your system integration testing, your staging, whatever needed. So what are some of the, the tools that are going to be relevant for when you're working within the Power Platform? So, most of you are going to be more familiar with using the Power Platform Admin Center. So from here, you can go in and actually create and manage your environments. Set up all the different key settings within your environments. Adding, going in and changing things like your base organization settings and so on. But when it comes to actually automating your ALM, likely you're not going to be interacting directly with your admin center, but it's just mentioned here as a sort of a point of reference. But you'll typically be working with tools such as a solution packager, which basically takes your solution zip file and it can unpack it, basically putting it into its its raw XML format, which can then be pushed into your source control system. And then once you actually need to pull it out and push it into an environment, you would then pack it back up into that zip file and push it into your downstream environments. The package deployer, so this is the actual tool where you can actually go to actually deploy your packages into your downstream environments. The configuration migration tool, so this is if you have any data that's not, of course, solution aware, as we know. So if you need to take data that's meant to be sort of configuration data, well, you can use the migration tool to actually generate basically a schema and a data file, and you can actually bundle these up into sort of a package that's created by the package deployer and included with your solution into your downstream environments. And then you have your command line interfaces like the Power App CLI and your PowerShell modules, and these will allow you to either pack up your solutions, build your plugin projects, actually go ahead and interact with some of the management APIs in the Power Platform, so such as doing operations such as creating environments, doing backup and restore, and so on and so forth. So for those who are not familiar with Azure DevOps, it's basically a platform that's provided by Microsoft, and what it really is good at is basically managing your whole DevOps process, really. So for those that are used to or have familiar with using Team Foundation Server, it's basically the evolved and cloud version of what was previously Team Foundation Server and Team Foundation Server Online. So you have the ability to use things like Azure boards, which are basically for work management and tracking things like your work items as you're working on changes. You have the ability to kind of visualize this using Kanban boards. So it's very good for things like that, tracking your user stories, your backlogs, issues, and defects. And then you have your Azure repos, which are basically your source control repository, and you have the ability to use a Git or the Team Foundation version control systems. Your Azure pipeline, so this is going to be really where the focus of our demonstrations today, but this is where you have the ability to actually start automating your continuous integration and continuous deployment pipelines. You also have your test plans, which are great for doing, supporting your manual and automated testing processes. So having the ability to run, automated UI tests, or basically where your QA team can go and actually manage, tracking and managing your testing processes. You have then your Azure artifacts, which are basically your package management repositories, where you would be able to actually store your build artifacts, but also manage any sort of dependencies or any other custom packages that you create. And it supports all the standard, well-known types of repositories and feeds, such as your NuGet, npm, Maven for those that do Java, Python, and so on and so forth. And the great thing about it is too, there's a very popular and diverse extensions marketplace. So you have the ability to really go and install these different extensions where you can then connect up to different first and third party applications and services, right? So that you can enhance the quality and capability of your continuous integration and continuous deployment pipelines. And these are all built by the community. So there's some really good extensions here, and some of them will actually be going through today. So in the Power Platform, there's two popular ALM tools that are available for Azure DevOps, and the one we're going to be talking about specifically using today will be the Power Platform Build tool. So this is the official tool set provided by Microsoft, and that's you can retrieve that from the marketplace and basically install these extensions into your DevOps organization, which I'll show you momentarily here. Another really good open source tool worth mentioning is the Power DevOps tool. So that's been around for a number of years, provided by Whale. It's a really good tool and another alternative if you prefer to use that. It's got some really good tasks in there, and also it does support some of your older versions, I believe, probably as far back as 2015. So, and those are particularly useful, I think, if you have, still some deployments that are on premise. So certainly worth checking out. Either of the tools are very good. There's no wrong one, but we'll be going through the Power Platform Build tools in today's demonstrations. So I'm going to go over kind of a couple of development patterns that are used and that are very common, and which ones I will, I'll recommend basically on a go-forward basis. So one of the more common patterns employed today by many organizations is basically what's called this shared development instance, or basically someone would also call it a coordinated export. So this is where you have multiple developers or functional consultants, citizen developers working within a single shared development environment, and your development environment is basically your source of truth, right? And so they basically do all your customization configurations in there, then basically coordinate, the deployment of those into downstream environments such as your UAT testing and then your production environments. So this pattern, it's good for very simple use cases, maybe for simple citizen development or small projects where you maybe only have a single developer or a very small team working on changes at a time, and it's very quick to set up. It's a low cost of ownership, but with that comes some potentially significant drawbacks. And so when you get to your more larger projects where you have large dedicated teams, it's going to be very difficult to basically export changes without including unfinished changes that other developers may be working on, right? And the chances for collisions where you're both making changes to similar components is much more increased when working inside of a shared environment. And so it really requires some discipline and really good coordination or collaboration between your team to basically get these solutions out without introducing defects. And another problem with this is that it's difficult to service your ongoing production environment when you're working on basically newer changes within the same environment. And so, like I mentioned, it's good for simple use case or simple projects, but likely wouldn't recommend this on any larger projects. So what a potential or common continuous integration, continuous deployment pipeline look like? So, you have here on the top left, typically you have your developer, or your functional consultant, or citizen dev doing your customization and configuration within a development environment. Once they're ready to, push those changes out to other environments, they would export it, hopefully unpack that, and then they would push that into your source control system. And ideally, this would then kick off an automated build trigger. So then your build pipeline would basically take your unpacked solution that's sitting in source control, pack it back up. It would start to run some quality checks against this solution. So you have things like the solution checker, which I'll get into in a little bit. You may run things like automated unit tests, or even automated UI tests if you choose as well. And ideally you would basically put a gate in here that if these checks failed, you could fail the build pipeline and then short circuit the process. Ideally, if it passed those checks, you would then basically spin up a just-in-time build environment, and basically you would take that unmanaged solution, you would import into the build environment. If that was successful, then you would basically export that solution out as a managed, and then you can basically take that managed solution, publish it as an artifact within your artifact repository, and then you can either manually or automatically kick off a release pipeline, which could then basically take that build artifact and push it into your downstream environments. Okay, so I've done a bit of talking. Let's jump into a demo in using Azure DevOps. So those are not familiar with the Azure DevOps interface. This is kind of what it looks like. So you have as kind of the things I kind of mentioned, you have your your boards, which are things for like your item tracking. You have your repos, and so this will basically be the source control repo, which will be storing our unpacked solutions. And then you have your pipelines, which is where we're going to actually go and start automating some of the build and eventual deployment processes. So right now we just have an empty repo initialized right now, basically calling it ALM demos. And as part of a build pipeline, we're going to eventually export out from the development environment, unpack it, and push it into this repository. So let's head over to our pipelines. And so we're going to go ahead and create a new pipeline. And so you have the ability to sort of, choose where your repository resides, but we're just going to go ahead and kind of use the classic editor without using any sort of a YAML, which is basically a markup language to kind of basically describe the steps within your build pipelines. But we're just going to kind of use the UI to assemble our build pipeline here. And so you're always going to have basically your team project where you have to select and which repository you want to basically scope this pipeline to. And so we're going to have our ALM demos repo, and we're just going to use, we just have a single branch in here right now, just the master branch. So we're going to use that. So we're going to keep those defaults, and we're going to continue. And so there's several different sort of templates you can choose when building a pipeline. So you'll have, commonly for your .NET projects, you may use like a template for building ASP.NET projects or, container-based projects. But in our case, we're just going to start with an empty job template and just add the tasks in ourselves. So the first thing you'll see here is that you always have an agent assigned to your job, and your agents, these can be basically Microsoft hosted agents in the cloud, and these basically get spun up on demand whenever your pipeline kicks off, or you have the ability to host your own hosted agents, whether that's sitting in your customer's on-premise data center or somewhere else. And so we're just going to be using the Microsoft hosted agents, and we're going to use basically just one that has basically Visual Studio 2017 installed, because it'll have all the things that we need for our purposes. So let's go ahead and start building adding some tasks into our pipeline. And so before I do that, before we can actually start using those Power Platform build tools, you would actually need to go over to the extension marketplace and actually install this extension into your environment if you have not already. And so it'll go through this and give you a chance to pick which organization you want to install this into. And so in my case, I've already gotten installed, so I'm just going to cancel out of here. But basically, once this is installed, a number of basically build tasks will now be available for you to then start making use of. And so, as mentioned, every time a pipeline kicks off, it's always going to be a new, basically a new VM provided by Microsoft. And so you have to ensure that we actually install the build tools as a first step every time. So if we just type in and install, we see here we have this platform and tool installer. There's no actual inputs really that we need to configure here. So it's basically just going to pull down the appropriate tools behind the scene that it needs to run the tasks. And so no additional configuration required here. So from here, we can then start actually using some more specific tasks that we're going to need to do. So the first thing we're going to want to do is actually basically take our unmanaged solution that's sitting within our development environment and export it out. And so I'm just going to hop over quickly. I have a number of environments set up for this demo. So we have our development environment, a build environment. Now, typically you would use this as a just-in-time environment, but because it's a bit time-consuming to spin those up on demand, I'm just going to have an empty one ready to use in our pipelines. And then you'd have your other downstream environments as necessary where your managed solutions would get pushed to. So I just have a system integration testing environment that we'll eventually use for deploying the managed solution once it's assembled. So I'm going to hop over to our development environment, and we just have a very simple solution for demonstration purposes called ALM test. It's just got a few entities, or I guess tables is the new name that we're calling them now, and a global option set here. So very simple, just for demonstration purposes, keeping it simple, and it'll ensure that the build doesn't take overly long because it doesn't have so many components. So we're going to hop back over to our pipeline, and we're going to type in the exports solution task, and we're going to add that to our solution. And you're going to see here it's going to need a number of configurations that need to be supplied. Now, one of the first things to be aware of is that you need to be able to essentially set up what's called a service connection to be able to actually authenticate to your development environments or any other environments that you need to basically pull the solution out of. And so what this actually requires to do is actually we need to basically set up what's called a service principal, which is basically uninteractive service account that can basically access the development environment and be able to actually export things out. And so this requires setting up what's called a app registration, and how we do that is we actually do this within the Azure Active Directory side. So I'm just going to hop over to the Azure portal here and under the Azure Active Directory organization. And so we have here your app registrations. And so I've already created one for this purpose, but I'll just quickly run through what needs to be done. And so basically we have your, a few key pieces of attributes that we need are basically going to need to know your tenant ID of your Azure AD. And because we're going to be using basically the client secret credential flow for OAuth, we basically need to have the app registration is going to have always a client ID and then basically a secret credential that we're going to need to set up, and so that it can authenticate to Azure Active Directory. And so here, basically, we've already set up a secret. And so one thing to know is when you're actually creating a new secret, you want to make sure you copy that value to your clipboard immediately, because once you kind of navigate away from the blade here or the interface here, you're not going to be able to retrieve it again. So I've already set this up ahead of time just to save time, but that's one of the key configurations that you need to go through. Now, the next thing we need to do is ensure that the actual the app registration has permissions to the common data service or Dataverse to be able to actually receive an access token, so that we can authenticate, and then we can then be authorized to do certain actions, such as exporting out the solution. So this essentially requires the user impersonation privileges, and so we've already enabled that. And another permission that I've kind of set up here, which just to simplify things, it's going to be useful for the solution checker. We also actually need to get permissions to use the get an access token to use the solution checker, so that we can perform quality checks against the solution. But I'll get a bit more into that later. But just as a heads up, these are the two key permissions that we have to set up ahead of time. And now, so what we also need to do is actually configure what's called an application user within your Dataverse database. So basically that they can map this app registration to an actual user within Dataverse, because you'll need to always be able to authenticate as a user within your Dataverse to retrieve data or perform operations. And so we essentially need to do this mapping activity. And so how we would do that is we would hop over to, say, our development environment, and we would need to essentially set up the user. So we're just going to quickly open up the environment so I can show you what this looks like. That might take a little bit of time. So while it's doing that, let's jump back into our pipeline. So we've already got some service connections set up. So I'm just going to select the dev service connection here, because that one has access into my environment. I'm going to give a solution name. Now, it's always recommended to use what's called variables instead of hard-coded values. And so what we can do is basically set up a variable name called a solution name, so that we can use that value in multiple steps later if needed be. So we want to make sure that corresponds with our solution name, ALM test. We're just going to set that there. And now we can actually reference it within our pipeline tasks. And so we need to basically set where we want to output the actual unmanaged solution within our pipeline. So I'm just going to paste in some of these values here. So basically, it's going to, on the build machine, it's going to put it in that root directory and give it the name of the solution name .zip. Now, because we're taking it from dev, we don't want to export this as a managed. We're just going to keep that as is. And you also have the ability to export out some of those system settings and configurations, such as your auto numbering and so on. But just for demonstration purposes, we'll just leave those unchecked. And so it looks like we're all good to go here. So now we need to actually then unpack that solution so that we can then prepare it for to be stored within source control. And so we need to basically take that solution input file from our previous, for where it was exported in the previous step, and then basically we need to basically unpack it and into our source control repository. And so we have what's called your build.sources directory. So this will correspond with our repo, our source control repo, and basically put it in a folder that's the name of the solution. Now, another step you might want to consider putting in before exporting, you may want to put in a publish all customizations, but be aware if you have other developers working in the environment, you may not want to publish all of these because they may have unfinished changes that they don't necessarily want to publish yet. So if you're working in your own isolated environment, it's probably a good idea to publish customizations before exporting, but in this case, we're just going to keep it simple and not included here. Now, the last thing we need to do is then actually take that unpacked solution and push it into our source control. So what we need to do is basically a command line or basically a script to be able to run those git commands. And so for this demonstration, I'm just going to use PowerShell. And so we'll add a PowerShell task. We're just going to do an inline script. And so we can just paste it directly into here. And so what I have here is just basically simple git command. So we have to do your git configuration. We're basically going to do a checkout of the master branch. We're going to create a commit, which basically includes all the unpacked changes that were outputted from the unpack step, and then we're going to basically push this into our master branch. So I'm just going to take this here, put it into the script here. And then we should be good to go. Now, an additional consideration as well, if we just basically save and run this right now, it'll fail because basically the pipeline doesn't have permissions into our Git repo. And so we basically need to give the pipeline access in order to use that access token so that we can push it into our Git configuration. And so we need to go into our pipeline. Oh, sorry, just need to go into our pipeline settings. And we need to check this option. So allow scripts to access the OAuth token. Okay, so let's go ahead and save and queue and let it run. And so while that's running, I'm just going to hop back into our Power Platform environment and jump back to actually showing how you set up that application user account. And so we'd go under the advanced settings and kind of into where you manage the security and users. We would add a new user. And within that actual new user, screen, there's actually going to be an additional form that we select that's specifically for the application user. And it's got a number of fields that we need to input. Because it's taking a little longer, I'm just going to briefly mention, basically we need to ensure that the client ID that we have from our app registration is set, and then basically fill in the rest of the information, such as the name and the email, which don't necessarily have to be anything significant because it's not an actual user within our organization. But once you populate that client ID, it should be able to detect all the other information, and then we can then give it a role, and we would need to give it the role of system administrator so that it can actually have that solution, deployment administrator capability, so that I can actually export out the solution. Because it's taken a while, we're just, for the sake of time, we're just gonna jump back to the pipeline. And so looks like we ran into a little bit of an issue here. Let's take a look. So the given solution name ALM test is not valid. Oh. So let's just jump over, take a quick look. Well, okay, so just for the sake of time, since we're running a little bit low on time, I'll just jump over to one of my already built pipelines from previous, just in case, we ran into demo issues. And so yeah, so it would have been similar to what we built, but we put in that publish customizations task. But basically what it would do is it would go through it. Once it's successful, it would then basically push that into the repo. So we'll just go ahead and run that, and then I'll jump back to the slide decks to talk a bit further. And so one of the key considerations, or one of the key practices that we should be moving towards, is moving away from an environment centric, where basically your environment holds the source of truth, but instead to shifting towards a source control centric, where your source of truth always resides in source control. And basically the benefits of these really is, that increased traceability and auditability that comes with any source control systems, right? So you have the ability to, basically we can, if you tie this with any work management system such as Azure Boards, you can actually tie any changes back to a specific work item. You have the auditability to see who actually pushed the changes. And then, you have the ability to, merge using, different source control or merge editors. So it's a lot easier to, merge changes than, using the normal user interface of the Power Maker portal. And of course, this has the ability so that you can basically cherry pick and only push out, changes that actually have been completed and are ready for, testing and release. And then, of course, you have, the ability to roll back changes or restore files that may have accidentally been deleted, because as we know, that's a little bit, once they're deleted in your environment, they're gone, right? Unless you have a previous backup that you can restore from. And so having that in source control, can mitigate some of those issues. And so really the optimal pattern that we should be, development pattern that we should be looking to use is the source control centric. And so you can see in this, depiction where you have, your developers working in their own dedicated development instances, and ideally their environments would only have basically the required managed solution dependencies, say from other solutions that are needed to do any customization and configuration changes. And so basically, once they're done their changes, they push that into source control, and then you have a build process, and that basically that build or pipeline will basically fetch from source control, assemble your managed solution artifact from build, and then that build artifact will be pushed all into your downstream environments. And so, of most importance, especially these days, you want to ensure that any changes you're making are going through certain quality gates and checks. And the reason for this is you want to, reduce the turnaround time for your testing cycles. You want to reduce the number of defects that occur based on your changes. And so what are some of the quality gates and checks that we can put into place to ensure that, higher quality changes are being pushed through and at a much higher frequency. So you have the ability to actually do, enforce basically policies within your branches so that, you have to do a pull request instead of just being able to push into master and potentially put breaking changes in. So, a pull request basically requires you can set up so that basically, there has to be that actual review of your changes from another colleague, and maybe it has to actually go through a number of automated checks to ensure that the build succeeds. So we would use things like the solution checker. You can run some unit tests, to make sure that your plugins or potentially your web resources or PCF components, are run through unit tests to ensure there's no regression, or at least if there is regression, it can be detected and it can be fixed. And of course, you even have the ability to do UI testing so that can increase the efficiency of and augment your testing team, right? And so that you can do automated UI tests and detect regression early, or even into your staging and production environments, you can do some automated UI testing to either smoke test the environment to make sure that the deployment was successful, right? So just briefly, the solution checker, as you'll know, it is basically it performs static analysis against a solution using sort of a predefined rule set based on best practices. So, it'll analyze things like your assemblies, your web resources, and your SDK message steps, and basically it'll detect any sort of issues based upon that rule set, and it'll categorize any issues, based on whether they have potential performance issues, usability, or supportability issues. And then it kind of classifies them by the severity, which is high, medium, low. And what you can actually do as part of your build process, you can actually set some thresholds, and that say if it identifies more than maybe 3 high severity issues, you can fail the build and basically prevent that from being pushed into your downstream environments. And so it kind of enforces best practices on your development team, and with the intent of higher quality solutions. And so what we can do actually is I'll jump back into Azure DevOps, and I'll actually show how we can implement this quality gate in place. And so I'm just gonna jump back. So I jumped over to my previous pipeline that I built previous to this demo, because the one we had built here kind of failed, but we can see that it was successful. If we actually jump into our source control, we can see that the unpacked solution components were indeed committed. And so what we can do now, actually, say we want to ensure that not everyone can just push changes into master without being, at least reviewed and run through some quality tests. We can go over to our branches here, so our master branch, and we can set what's called a branch policy. And so for setup for this demo, I've gone ahead and actually built another pipeline that'll basically run as part of this quality gate. And so what this looks like is that it'll go through, pull that solution from source control, your unmanaged solution, pack it up, run the checker, the solution checker to ensure there's no issues detected, and if it's within an acceptable threshold, it'll then basically take that solution, it'll pack it up, or it'll take the packed unmanaged solution, import it into the build environment, and then basically export a managed solution, which can then be basically published into the artifact repository, which will then be pushed into the downstream environments. And so I'm just going to jump back over to the branch policies. And so we can have basically set up a build validation so that it'll actually run this quality gate pipeline as soon as basically a commit into the master branch is detected. And we can even do things such as basically adding a minimum number of reviewers. in my case, I only have myself in the environment, but let's just say we wanted to have another reviewer to make sure that they can review the merge changes and ensure that there's nothing that seems out of whack, and then they can kind of go ahead and approve it. And assuming it passes the quality gate build, we could then actually accept the pull request, which will then merge any of the changes into the master branch, and then it can then basically go into the main line and make it out into the release. And so what we need to then do, actually, we need to make a slight adjustment to our original, excuse me, our original build pipeline, so that now instead of just doing a straight push into our master branch, because if we just do a push, we're going to get an error saying that pull requests are now enforced on the branch, and so now we actually need to change this to create a pull request instead of just doing a straight push. And so I'm just going to pop in a bit of commands here, and basically I'm just using what's available through the Azure Repos API to actually generate a pull request. And so we're basically just going to call that API endpoint, and so we have a few build attributes that we actually are available as part of the pipeline, such as the project name and the build repository ID, and basically the endpoint that we need to create the pull request. So if we just updated our script task here, and then if we saved and basically queued that, it'll then basically generate a pull request, which will then kick off the quality gate pipeline and run through that build to make sure that basically it can build correctly, it passes all the quality checks, and then is available for release. Now, because we're running a bit short on time, it looks like I won't be able to show you that end to end, but the final piece to that would then be actually creating a release pipeline. And so if we hop over to our releases, we can basically add in what's called a trigger. We could trigger that, run this deployment pipeline basically whenever the artifact, which is that managed solution, is published into the repository. We could then trigger this this deployment pipeline, and so we could enable this pull request trigger because that's what we want to have it based on for this system integration development environment. So, for example, we may want to actually push it into the system, into the SIT environment, so that we can do some maybe additional quality testing like UI tests, and to further ensure that the build is successful and that the managed solution actually is assembled correctly. And so this release pipeline would be very, very simple. It would just essentially, you could run the solution checker against the managed solution, and then essentially import it into the downstream SIT environments. Okay, so just a few minutes here, so I'm just gonna quickly wrap up here and just kind of go over a few best practices that you should consider integrating into your process. So the idea of solution segmentation was actually introduced in version 8 or 8.2, I believe, and this allows you to essentially only include components or subcomponents that have a change into your solution. So instead of including the whole entity, which you had to do before, you can just pick up maybe the fields that have changed and include that in your solution. And really, the benefit of this is that it reduces the complexity of the solution. It's very easy to see what changes are being made by a developer. It'll significantly reduce the time it takes to actually import the solutions into the environments, and this becomes particularly important if you're doing multiple builds and deployments every day or multiple times a week. And so having that reduced turnaround time can certainly be significant over time. And of course, by reducing the amount of components that are inside of a solution, you significantly reduce chances of team collisions. Now that's not to say that you should still certainly try to avoid, developers working on the same components at once, like forms, because that can be still difficult to merge within your source control. So, you still want to try and segment working on components where possible. And so the idea is, well, that each developer should work in their own segment and environment if possible, and essentially it should only contain dependencies, and those dependencies should be installed as managed solutions so that you can do the development, or that can facilitate the changes required to be done. So say if you have a base solution that encompasses core changes, and you're working on additional changes, that you want to take that core solution, install it as a managed solution in your development environment, and then you go ahead and make your new solution changes. And of course, it's always recommended that any non-development environment, your solutions should be deployed to those downstream environments as managed solutions. Okay, so just to recap and some final considerations. So your development strategy, we should be shifting from, as I mentioned, environment specific to a source control specific, so that source control is a single source of truth. By implementing sort of a DevOps mindset into your organization, it can achieve faster velocity, meaning faster time to market, and just overall higher quality solutions. You should really look to introduce quality checks into your automated pipelines, to reduce the amount of bug fixes, detect regressions before it makes it into production, right? Because no one wants to see an unhappy customer finding issues in production. And finally, don't wait to start automating. You don't have to have a full end-to-end, fully automated process from start to finish. Just starting simple and having just even an automated process for exporting your solution, bringing to source control, can bring immense value and return on investment over time. So if you're just getting started, just start small, start somewhere, and you'll start to see those gains almost immediately. And it looks like we're just about at time, and so I'm not sure if we have any time for questions, but if we do, feel free to fire away. Victor, do we have any questions from the chat?
We got a few discussions going on. What I will do is I'll let you respond to those on the chat itself. It's really great that folks are starting to talk about repo branch strategies, which is the segue to this particular presentation with Rafael. But he's doing he's showing things a little differently, but nonetheless, I think it will clear some of the questions that folks have. So I will quickly switch. Let me just stop the recording real quick, and then bring